Hello friend, hi everyone. So today we are going to discuss this problem. This is known as 3-point oscillator. How it become oscillator, we will see after the analysis. And so we have to calculate the input impedance of this. So to calculate input impedance, output impedance, what we need to what we have to do, we generally use a voltage source at the input and we calculate the current through that terminal. Vt is a test voltage we are applying here, and we are calculating It, which is coming out from the Vt, and the Zn will be Vt upon It. Now here we have to calculate the small signal Zn actually. So but we will not create the complete small signal model of this because that will consume more time. So we will directly find out what will be the Vt upon It of this and how it can become an oscillator. Now to calculate Zn, here we will see we have Vt we have applied, Vt is known, we have to calculate the It. So to calculate It, let's see, It is flowing from out from this Vt and it will go from here because there will be zero current in this direction because this MOSFET has, this is the gate terminal of the MOS, so which has infinite impedance. So there will be no current through this. So whole current will come from here and it will go from here to here in the second capacitor. Now there is another current which will come due to this MOSFET, which will be Gm of this MOS and VGS across this MOS. So now let's see, this is Vs, Vg for this MOS is Vt. So let's first calculate the ID current. ID current is the MOS current, which is Gm into VGS, where Vs is voltage across this load cap, which will be 1 by SCL into total current through this. Total current through this will be IT, which is the I test, plus ID, which is the current coming from the MOS. So from here, we will just put the value of ID here. ID is Gm into VGS, 1 by SCL into Gm to VG. VG is Vt. VG is Vt. V gate is here. So where T test is voltage is applied, minus Gm upon SCL into Vs. So from here, we will just calculate the Vs. So Vs will be 1 plus Gm upon SCL is equal to 1 by SCL into It plus Gm upon SCL into It into Vt. We can simplify it here. Vs is equal to It upon SCL plus Gm plus Gm upon SCL plus Gm into Vt. Just multiply SCL here and SCL will cancel in both sides and it will come like this. So we can say this is equation number 2, we can say this is equation number 1. Then now, so this is with this equation came from the current equation at this node. Now we will go through this path and use the KCL. So KCL here will be Vs plus It into 1 by SC1 is equal to Vt. What is this? Vs is the voltage at this terminal plus voltage across this capacitor is equal to Vt. Simply. So just put the value of Vs here. Value of Vs is It upon Gm plus SCL plus Gm upon SCL plus Gm into Vt plus It into 1 by SC1 is equal to Vt. So this is 3. So from 2 and 3, we are just putting the value of Vs here. So now just separate the It and Vt. It into 1 by Gm plus SCL plus 1 by SC1 is equal to Vt into 1 minus Gm upon SCL. So from here, Vt upon It will be just, it will be SC1 plus Gm plus SCL upon SC1 to Gm plus SCL SCL so here it will be Gm plus SCL, this one. So it will be Gm plus SCL minus Gm upon Gm plus SCL. So this and this will finish Okay, it will come like this. Okay, it will be actually, it will come Gm plus SCl upon Gm plus SCl minus Gm. So this will cancel this will cancel this. It will come SC1 plus Gm, SC1 to SCl. You just put IT here and this one there. You can easily get this. So from here, what we will see, it is 1 by SCl plus 1 by SC1 minus Gm upon, or we can say Gm upon S square C1 C2 C1 Cl. From here, if we just put instead of S Gm, we put J omega, so it will be like this, plus Gm upon J square omega square C1 Cl. So it will be 1 by J omega Cl plus 1 by J omega C1 minus 1 upon omega square C1 C2, because J square is minus 1. So this negative resistance make it eligible for the oscillator. This negative resistance will make it eligible for the register for the oscillator. So now you can see we have this, and this, and here Zin is this one. Now this negative resistance, if we will put a inductor here between this and this, okay, so this the inductor will have some resistance. So this resistor will nullify this resistor of the inductor at some frequency, then it will oscillate like a LC tank circuit. So it has 3 point, actually 1 2 3, that's why it is also known as 3-point oscillator. The important property here is this negative resistance. Thank you.